All right, moving on into Unit 2, the 2.1 notes where we're solving one-step equations. After this lesson, you will be able to determine if the value of a variable is a solution to an equation, and then you should be able to solve a one-step equation. All right, so let's start off defining what an expression is. An expression consists of algebraic terms that are either being added, subtracted, multiplied, or divided. An equation is where algebraic expressions are set equal to each other. All right, and then a solution to an equation is a numeric value that can be substituted for the variable in an equation that would result in a true statement. Okay, so let's go ahead and test that last definition, the solution to an equation. With example number 1, it says determine which of the equations has x equals 4 as a solution. Okay, so again, as we stated above, right, for it to be a solution for the equation, we need to substitute that numeric value in for the variable. So for part A, I'm going to substitute 4 in for x. Okay, so wherever I do a substitution in an equation, I usually use parentheses just to kind of highlight where the substitution happened. All right, so once you do the substitution, then you look to simplify each side of the equation. So on the left side, I can do 4 minus 5, and that gets me -1. Okay, so again, all I did was substitute the 4 in for x on the left side, and I simplified that left side down to -1. So now you see here I'm left with a mathematical statement that says -1 equals 6. Well, we know that is not true. So what that tells us is that x equals 4 is not a solution. Okay, so here, not a solution. X equals 4, not a solution. All right, move on to part B. Again, I'm going to sub in 4 in for x. Simplify the left side. All right, again, notice I only worked where I had opportunities to simplify. I didn't change anything. I didn't move anything around. All right, I subbed in 4 in for x. I simplified 5 times 4 to get 20. So now I'm left with this statement, 20 equals 20. Now that is a true statement, right? 20 does equal 20. So that means x equals 4 is a solution because we are left with a true statement. All right, moving on to part C. Again, we're testing to see that is x equal 4. Is that a solution for this equation, part C? So again, to test that, I'm going to plug in 4 in for x. So now 10 over 8 is a fraction, so I'm going to do this. I'm going to make 4 fraction by putting 1 underneath. Because I want to simplify this left side. Okay, so I'm going to multiply fractions. So 10 times 4 is 40. 8 times 1 is 8. And just working on the left side. Here on the left side, I have 40 divided by 8, which is 5. All right, so then I take a pause, look at what I'm left with. I'm left with the statement that says 5 equals 5, and that is true. So that means x equals 4 is a solution. All right, so I'm going to give you some time to do part D and E, determining if those values for x are solutions for those two equations. All right, for part D, again, we want to check if x equals 3 is a solution for the equation. So we're going to plug 3 in for x. Now we have x in two different places. Okay. So once we plug the 3 in for x, now we're going to go ahead and evaluate. So we want to simplify this left side. So negative 2 times 3 is negative 6. And then when we add it to 8 equals 2. On the right side, we plug 3 in for x. 3 times 3 is 9. 9 minus 7 is 2. So now we're left with this statement that says 2 equals 2. Again, that statement is saying that x equals 3 is a solution to the equation. All right, moving on to part E, when we plug negative 2 in for x. All right, so again, we're going to test to see if x equals negative 2 is a solution. So we plug negative 2 in for x. Simplify. The left side comes down to negative 13. Plug negative 2 in for x. Simplify. The right side becomes a 6. We look, negative 13 equals 6. That is not true because that statement is not true. X equals negative 2 is not a solution to the equation. All right, so when it comes to solving equations, the goal is to get the variable by itself by using what's called inverse operations. Okay, so inverse operations you want to think of as the opposite operation, all right? But I'm going to be using the term inverse because that's what you're going to be hearing most throughout the next few years in your math classes. All right, so the inverse operations, what we're going to talk about here for the four main operations. All right, so what's important here when we're solving equations, trying to get the variable by itself and using the inverse operations, to do that, you need to remember that you have to do it to both sides of the equation, both sides of the equal sign. All right, so for addition, the inverse operation, right? So if you have addition in your equation and you want to get the variable by itself, right, the inverse operation is you will, right, subtract both sides. All right, so the main part here is that you will subtract. All right, so here's an example over here. So x plus 4 equals negative 6. So again, we want to isolate the variable. We want to get x by itself. So we need to get rid of this plus 4. So that means we need to do the inverse operation of plus 4, which would be minus 4. And what we do to one side of the equation, we have to do to the other. Okay, so again, we're doing the inverse operation, which is the opposite operation, right, of addition, which is subtraction. So when we take plus 4 and minus 4, those go away, and you're left with x by itself. And on the other side, we have negative 6 minus 4, which is negative 10. For subtraction, right, you will add a value to both sides. All right, so we move on to the example. We have x minus 12 equals negative 7. We want to get this x by itself, so it means we need to get rid of this minus 12. So we are going to do the inverse operation of minus, of subtraction, which is addition. So we are going to add 12 to both sides. On the left side, all right, when you do inverse operations, they cancel each other out. So now we're left with just x. On the right side, negative 7 plus 12 is a positive 5. For multiplication, all right, so I think you've hopefully figured out the pattern here. So you will divide both sides. So here we have 4 times x equals negative 36. All right, because the 4 is being multiplied the x to get rid of it, so the x is by itself, we're going to do the inverse operation of multiplication, which is division. So we're going to divide by 4 on both sides. All right, so when you divide by 4, 4s are going to cancel. You're left with x, and on the right side, negative 9. For division, you will multiply to both sides. All right? The inverse operation for division is multiplication. So here we have x divided by 3. So to get x by itself, we need to do the inverse operation of division, which is multiplication. So we are going to multiply both sides by 3. The 3's are going to cancel. We're left with x on the left and 24 on the right. So for all of these, we've solved the equation by isolating the variable x. All right, so let's do some of these together here. For part A, we want to get x by itself. So we see this negative 7 here. So now we need to be careful a little bit with these because we do see the addition sign here. So we think we might need to subtract. In fact, for this, because it's a negative 7, we want to do the opposite, the inverse of that, which is add 7, right? So we need these things to cancel, right? Doing a minus 7 is not going to get this variable isolated. So we're going to add 7 to both sides. Here, a negative 7, a positive 7 cancel each other out. So on the left side, we're left with x, and on the right, 27. For part B, solving for x, we are going to do the inverse of adding 9, which is subtracting 9. Do that to both sides. We get x by itself, and then on the left, 18 minus 9 is 9. For the next problem, it's negative 12 times x, so that's multiplication. So the inverse operation for multiplication is division, so we're going to divide by 12, and this is division. Oh, it should be negative 12, excuse me. All right, so then we're left with x on the right, and 48 divided by negative 12 is negative 4. This next one's a little tricky in that we have a fraction. So when it comes to fractions, again, we want to do the inverse, right? So we want to maybe rewrite this in this manner. So we see this one's kind of a combo. All right, so here we see a division by 4. So we're going to undo that division by multiplying by 4 to both sides. Now just the 4's cancel, so I'm still left with that 3 times the x up top. Okay, so now we're not quite done yet because the variable is not by itself. Here it's 3 times x, so I'm going to do the inverse of multiplication, which is division. So I'm going to divide both sides by 3. So I get x is equal to negative 12. I'm going to skip over to the last problem here. You have x minus 10. We want to get the variable by itself, so we're going to do the inverse operation, which is add 10. So that's going to cancel. So you got an x on the left side, and then on the right side, negative 10 plus 10 is 0. Okay. All right, so that's it for today. Go ahead and move on to the homework for 2.1.